Today's show is sponsored by BMC, and BMC wants to know, is your business on its A game? The A game is when systems are intelligent by learning from markets, where automation is paramount yet effortless, and when technology and people work as one in an enterprise. The A game is your business at its absolute best. BMC calls this the autonomous digital enterprise. Find out more at bmc.com/agame. That's bmc.com/agame.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well. We are rolling into the last week of October, kind of a crazy time. Not only do we have some big events still happening on the tech calendar, we've got AWS reInvent coming up, we've got KubeCon North America coming up, but we also have some big global events like the U.S. elections are happening here in the early part of November. We've got COVID spiking all around the world. So, hang on to your hats. I think the last 2 months of the year are going to be really, really crazy. Hopefully in a good way, but some craziness could be ahead of us. So keep everybody safe. Stay safe yourself. Stay healthy. Help your friends. Help your neighbors. Do what you can to be part of this community, and hopefully we can all get through it together and get into 2021 with something new. So with that, let's jump right into Cloud News of the Week. A couple of interesting stories we thought we'd mention. It's going to be a short Cloud News of the Week, but the first one is Microsoft is building out a new business unit within their Azure division. It's going to be called Azure Space. It's going to focus on kind of the evolving space sector industry. So satellite data, space missions, global networking. And one of their very first partners is SpaceX. So Elon Musk's company, SpaceX. SpaceX is going to provide Microsoft with access to its Starlink low latency satellite-based broadband network. And this is going to be used by Azure Space for a new offering from Microsoft called the Azure Modular Data Center. So think of this as a little bit like the AWS offering that is the big truck that will come and get your data. The difference is this seems to be sort of a modular all-in-one data center. So it's not just coming and getting your data and driving it back to Azure, but this is actually going to be kind of what seems to be a refresh of something that like Sun and some other folks did more than a decade ago. For those of you that might remember, they sort of did container-based data centers. These are going to be obviously tied to the Azure cloud, the Azure operating model, and so forth. So interesting to see the space segment explode as much as it is. We just saw an announcement from NASA that there might be more and more water on Mars, on the moon. So people are once again excited about space, which is always cool. This is probably a segment that Aaron should read because he is all into space and Mars and moon and all sorts of things. The other thing was Splunk made a couple of acquisitions this week. So Splunk acquired two companies. One was a company called Plumber, Plumbr, so Plumber, based out of Estonia. Very, very early acquisition for about $1.8 million, so just a few people. And they also acquired a company called Rigger, based out of Atlanta. Both of these were focused on the APM space. So we saw Splunk, just recently roll out their acquisition of SignalFx. They've been on a buying spree here recently, and they are looking to expand out their APM and observability space. So both Plumber and Rigger now join Splunk, or will be joining Splunk shortly. So exciting to see that space continue to consolidate in some areas and expand in other areas. So very interesting space. With that, I'm going to kind of wrap up Cloud News of the Week. Wasn't a lot of news, but we will be digging in more next week. There's all the earnings announcements are going to come out in the next week or so from the cloud providers, Microsoft and Google and Azure, or AWS and so forth. So we'll see how much the pandemic has been affecting them. And obviously we'll probably have some insight as to what's going on in the U.S. election by next week or hopefully the week after. Hopefully sooner than later. So with that, we're going to wrap up, have an interesting conversation with our friends from Datadog coming up right after the break, talking about application profiling. Today's show is sponsored by Cloud Academy. Listen up, y'all. This is a great offer. With everyone using the same cloud platforms, winning and losing comes down to having the best talent to build products better and faster. Cloud Academy is the training platform of choice for Fortune 500 companies and thousands of tech professionals around the world. Thousands of video courses, learning paths, practical hands-on labs in real-world cloud environments, Cloud Academy has tools designed to help teams assess, build, and validate critical cloud skills. Most importantly, Cloud Academy stays agile, challenging you with new content, labs, and tons of features that ensure your skills stay relevant and everyone can level up. They cover everything from cloud certifications to DevOps to security to programming languages. You can get started now at cloudacademy.com. For a limited time, Cloudcast listeners can lock in 50% off the monthly price for life. Just put in the coupon code CLOUDCAST at checkout. It's a great way to pursue certifications or just build cloud expertise. Again, that's cloudacademy.com and use the coupon code CLOUDCAST to lock in 50% off the monthly price. Today's show is sponsored by Datadog, a cloud scale monitoring platform that unifies metrics, logs, and traces from technologies like Istio, AppMesh, and Envoy. Plus, Datadog's Service Map automatically plots out the dependencies in your microservices architectures for seamless, context-rich troubleshooting. With rich visualizations, algorithmic alerting, and more than 250 vendor-supported integrations, Datadog allows you to monitor your distributed applications in real time. Start a free 14-day trial today by visiting datadog.com/cloudcast, and Datadog will send you a great free t-shirt. That's datadog.com/cloudcast. And we're back, and folks, as you know, we are seeing more and more companies who have become really dependent on the applications that interact with their customers. It's not just software is eating the world, but software is becoming the way that we interact with our marketplaces, the way that we interact with our customers, with our internal teams, how we interact with data. And so being able to have applications that are responsive, that we understand what happens when they have problems, is becoming not just critical to our business, but important as to how our businesses are perceived and how customers interact with us, how they tell their friends about what they do, how our APIs interact with each other. And so it's important that we be able to not only understand when they're running great, but also when they have challenges. And so I'm excited today to bring on a couple of folks from our friends at Datadog to kind of help us understand what are some of the more modern techniques that are happening in terms of how we profile our applications and, most importantly, make sure they're running great. So excited to have both Hugo Kaczmarek and Markus Hirt from the Datadog team. Markus and Hugo, welcome aboard. Welcome to have you on the show.
Thanks. Good to be here.
Thanks, Brian.
Yeah, so good to have both of you on today. Before we dive into it, and also so folks can get a sense of your voices and so forth, Markus, why don't you start? Give us a little bit of your background and what brought you into into the space in terms of what Datadog's doing engineering wise, whether it's observability, APM, profiling. Give us a little bit of your background.
Sure. So my background is I started a JVM company together with friends right after school that was acquired in several stages by American companies. And then eventually I ended up in the Java Platform group at Oracle. And I spent quite a lot of time there doing things that had to do with observability and profiling, especially production profiling. I was really quite happy there. I didn't have any plans of leaving, but I had tried to push some technology that I wanted to develop for quarter after quarter. And they said that, we don't really have staffing for it right now, but, maybe next quarter. And that happened a lot of times. And then somebody from Datadog reached out and said, hey, why don't you come over to us and build it here? And of course, that was too exciting to turn down. So I moved to Datadog.
Yeah, very cool. Very cool. And Hugo, what about you?
So I started in data science, technology companies, software companies, machine learning companies. And I joined Datadog around 2 years ago, wanting to build new products. I'm a product manager, and I've been for the past 6 years. And around a year and a half ago, Markus and I started the Profiler product at Datadog. And the main goal was to build something really new that didn't exist on the market, I would say, and that would help developers immensely in shipping efficient applications in production.
Yeah, excellent. No, it's we've been lucky to work with the Datadog team for a while, and over again, the constant that we hear is the ability to give people the freedom to go create, to have to want to move beyond kind of the original core roots of Datadog. So it's very cool to hear that you guys have been building the thing that you've been passionate about building. Let's talk a little bit about profiling in this space that you guys are working in. Production environments used to be pretty sacred. They were, don't touch them, leave them alone. We don't want them to go down. we've evolved. We've started to see, people begin to understand these concepts of chaos and chaos engineering. And so, testing environments, blue-green environments. And so, production has become more of a place where obviously we want stuff working all the time, but we also have to be able to instrument it such that, we can deal with the fluctuations and the challenges and the problems it have. Talk to me a little bit about this concept of profiling and why it's such an important thing for our applications in production, as opposed to maybe thinking about what we used to do in testing or dev and test environments.
Right. So profiling is, of course, the art of trying to figure out what's actually going on in your application, of software profiling. And the remedy can't be worse than the ailment or the sickness. So you actually need to do this in a way that is very low intrusive if you're trying to do this in production. So you need to be really, really careful about how you go about profiling things. And I think we've done a great job there, balancing the various kinds of data points that we want, but also the performance requirements for getting that data. And that's basically one of the things that I spent a lot of time looking at Oracle.
Yeah.
So,
yeah. And can you talk a little bit about this concept of, like you said, the remedy can't be worse than, like how do we find that balance between, yes, I want to find and fix everything, but, everything has a cost, whether it's CPU or memory or extra code. How do you find that balance?
Yeah, you basically need to allow yourself a budget and set a goal for you to try to reach in terms of the overhead. And you need to start looking for data that you can capture in a way that is a constant in the cost. So somehow try to bring the problem back to a point where you get the data at a constant cost. So people might be prepared to take 1%, maybe 2% overhead in CPU for doing profiling, but much more than that, and it starts becoming something that they need to pay for, even just through the overhead. So you need to be exceptionally careful when you do these things.
Yeah, and how do you find that people figure out what that right number is? Is it a lot of experimentation, or have we gotten to a point, say with Java applications, where we kind of understand what's going to be acceptable and where things will get too slow, for example?
Yeah, so absolutely. We have done this for a very long time. We do know techniques and patterns that can be used to bring things down cost-wise, and still get us enough resolution so that we can actually solve the problems. But sometimes you get really, really surprised. So, for example, so Java has this built-in recording engine. It's called the flight recorder. And that's really what's been driving the production time profiling technology on the Java side of things for a very long time. And it's basically an event recorder. So you can think of it as a data flight recorder for an airplane. It records what is going on in the JVM, so both the application and the runtime. And at the end, you get some data out of there, right? And there are events, for example, for capturing exceptions and errors. And we thought that, errors defined as they are, in Java, as something that is usually not recoverable. Something critical has happened. You might have run out of heap memory. You might have, you can't link anymore. Something really catastrophic has happened. And you'd think that doesn't happen that often, right? So we had that thing on, and we were capturing errors. And an open source framework that shall remain unnamed, we're actually throwing look-ahead success, which inherited from error. So there goes our assumption out the door. There were gazillions of them being thrown, and this is a framework that was used everywhere. So sometimes you get surprised and you need to build something else.
Yeah.
So we built our own exception profiler.
Yeah. Okay.
To handle that case.
Gotcha.
And that's what we started with, in Java, using Java Flight Recorder, but also on the other languages that we support right now, so Python and Go, and we have a lot more that are in development. We try to apply the same principles as we did on Java. So that means, as you said, trying to have as minimal CPU overhead as possible, and more importantly, no pauses, so no additional latency to your requests. And we've recently published on Datadog blog post a blog on how we built the Python profiler.
Okay, good. Yeah, we can get that into the show notes. Hugo, I want to kind of talk to you about from a product perspective, product manager perspective. Everything that we do these days, especially as we work in the cloud, there's always a little bit of a shared responsibility between what the application owner does and what the cloud service provides. Talk to me a little bit about, kind of where Datadog's continuous profiling stops and starts, and then what's the responsibility on the customer or the application owner? Where is that work in conjunction, and what are the kind of the demarcation points?
So, I mean, if we talk frankly here, we think at Datadog that every application owner should run profiling continuously in production, and that for a couple of reasons. One is, a lot of customers told us that they discovered some things they never knew could even existed by turning it on in production. And if you relate to 10 years ago, and I remember at my previous jobs, engineers would spend weeks trying to reproduce in staging, production load, and try to reproduce some issues they experienced in prod, and without success, as you may have guessed. Sure. And now, some of our customers tell us it's wonderful the things we were able to uncover by running profiling in prod. So it's like, I feel it should be the responsibility of every application engineering team to, I would say, weekly or daily check what's happening in my code, what's weird, what's changing, and especially release after release, which methods, which part of my code are less efficient now that I've released new code. And I'll give another example. We spoke recently with a large customer, and they said, it's cool to have that product because up until now, we've been shipping features to our services, and we've just been adding more cores to our servers. And that's it. That was the solution for adding, I would say, features that are consuming more CPU. And now, regularly, they can check, like, okay, what's consuming more as I ship new stuff?
Yeah, no, it makes sense. I would assume, your typical customer, your typical application team, it would make sense to them initially, like you said, they're running it in their development environment or their test in QA, and then maybe originally they're hesitant to do it in production. What do you find is often the light bulb moment that says, hey, we should run this, and we should, like you said, continuously run this in production as opposed to just kind of a periodic thing? Is it really just, is it a comfort level that it won't impact the application, or is it a certain amount of new visibility and data insights that they just say, hey, I no longer can live without it? Have you found kind of what's that mindset that helps them make that change from don't do this to run it continuously?
As you said, so there are a couple cases. I think there are two main cases. One is the first one you mentioned, which is, we run it on our staging, on dev. We try to see the overhead with and without. We spend a couple sprints measuring that overhead and validating that it's not going to impact prod. And then they turn it on. So those are, I would say, some conservative customers, but that are eager to experience. And then we have another set of customers who said, I would never run this in production. And they would do that and so run it only in staging for a couple weeks or months. And then once they see a big outage in prod, and they notice that outage has to be somewhere in my code, like caused by something in my code. And I wish I had some profiling data at that point. And I cannot start a profiler right away that's going to change everything. I would have wanted to have that profiling data already there. And so that's how I would say a good chunk of our customers actually start turning it on everywhere in prod. It's at their first outage when they realized they needed this data the most and they didn't have it.
Yeah. And, when you talk about profiling, is it something that you find, applies more towards like SRE teams because, they're there to sort of help make sure the application's, living productively in production environments, or does it tend to apply to the application teams? Like sort of who's the person that says, I need this the most? It's going to help me help my job the most. Who do you find? Is it a team? Is it a certain kind of role or skill that it most applies to?
So I think the people that need it the most are the application engineers, because profiling is going to point something that is inefficient in your code, and it's only application engineers that have to fix this part of the code, and they have the knowledge of is that inefficiency kind of expected or not, and they know how to fix it. But it doesn't mean that profiling is useful only to them. It can be useful, as you said, for SRE, because SRE engineers constantly look at how their resources are used on hosts, on infrastructure. And this resource consumption can be explained by profiling. And finally, you also have the higher level management, I would say, that looks at their overall stack and that are always wondering, where can I save some money? And profiling is, I would say, the best tool to point and tell where you can save some money. And we have some great examples of success stories internally at Datadog that we will soon publish on our blog post as well.
Okay, very good. Markus, I want to come back to you, as somebody who's worked very closely, not only with the code, but with the developers, how much of a learning curve or how much code does a typical application team have to write in order to be able to take advantage of these profilers? Is it a small amount of work? Is it a big learning curve to kind of understand how to instrument this properly? What's if I'm a typical Java developer, Spring developer, whatever, like how much work is it to start taking advantage of this?
So it depends. I mean, when we're talking about profiling, there are so many different kinds of profiling that we're actually doing continuously. So some of them are easy, quite easy to conceptually understand. So CPU profiling, for example, you can just do that. Look at the flame graph, and as soon as you've grokked how to look at a flame graph, you can start saving money. So that kind of profiling is something that most people are quite comfortable with, and it doesn't take that much time to get into the thing. Then there are other kinds of profiling that require a deeper level of understanding, and we're really trying to make it easier to work with that kind of profiling data by providing analysis, right? So we might be discovering that you have some JVM induced pause times for Java, for example, something called safe points. And most people don't know what a safe point is, nor do they care until they actually have to care. So, if we discover something like that, we might have a rule that triggers, and then you can go to the analysis page and we will explain what a safe point is. And we will explain why we think this might be a problem and what thread initiated this particular safe pointing VM operation and stuff like that. So it can make it easier and make it more available to you, even other kinds of profiling that we're doing that might be harder to understand, or that you might just not have been confronted with before. So we're trying to make that available in a better way. And and there are a lot of different kinds of profiling that we do.
Yeah.
So I find that to be exciting.
Yeah. So let's dig into that a little more. Do you find that, are there certain types of applications where I mean, obviously you can say, look, every application should be doing this, but do you find that there are certain types of applications, whether that's, real-time streaming, things that have latency to them, or, something else that sort of becomes the highest priority for where to start profiling? Or does it really just depend on, the team saying, hey, I need visibility that I didn't have before? Have you found any patterns in that sense?
Yeah, so it really depends on what runtime characteristics you need for your application, right? So that is something that we can't gather for you. We can't understand whether or not your application has some solid, hard throughput demands, but no demands in terms of responsiveness, or if it's something that really needs to be responsive and you would do anything to bring better response times. So we are providing you with different metrics and different numbers that might help you to understand the general idea, sort of an overview of what's going on in your application. And then you can make a decision that, hey, these latencies are not acceptable. I can't have post times that are this large. It's not acceptable. And then you might go look at the allocation profiling data, or you might be totally fine with post times, and all you want is throughput, and you're maxing out all your CPUs, and all you want to do is save money. So, you want to be able to run your application on less hardware. So you go to the CPU profiling information, and you're trying to utilize, make your program execute better. You require less CPU. So okay. It depends.
Okay. So yeah, but it does seem like, depending on, again, whether it's you're trying to identify a problem, or you're, trying to solve a problem. Like you said, I want to reduce costs. I want to reduce latency. I want to have greater visibility. There's kind of a profile that matches those types of problems. I get this, at least in many cases.
Oh, absolutely. Yes. So we have various different kinds of profilers running that help you to solve and observe these problems. So we are kind of a little bit crazy in this area as well, because, this thing, the continuous profiler, these days you actually release software maybe even several times a day, right? So something might happen, and if you weren't continuously profiling, you might miss that entirely, right? So we are trying to give you observability on a level that allows you to go into the very nitty-gritty details and associate things, right? So we're really trying to do the deep distributed tracing thing here, which is kind of crazy, but it's because it requires you to be able to handle pretty large quantities of data.
Yeah.
So what I mean by this is, if you have an application that is running exactly the same, you have the same version always, the input is always the same, you're always exercising exactly the same part of the code, nothing ever changes, input, everything is static. Then you could pretty much, for whatever time period you're looking at, you could basically just say, hey, I'll take 50 samples or 100 samples, whatever resolution you want. And over that time period, you perfectly randomly sample those 100 points, and you're good. That's all the data you need. Now, if you're releasing several times a day, doing that on a time scale of a day is not acceptable, right? So if you're trying to get the profiling data down and associate the profiling data down to, let's say, a long-lasting distributed trace, now that's when things become really exciting. And we can do this. We can basically get 100,000 data points per minute with stack traces and all kinds of profiling data, and still just have 2 megs per minute approximately with all this data, and do some really exciting things.
Interesting. Very, very interesting. I obviously the market around this has really exploded a lot. Datadog is in a lot of different places. If people are exploring this place, and they go, well, I hear about profiling, and I hear about observability, and I hear about logging, and I hear about APM. Like, do you have sort of an easy way to explain to people, does each one of those kind of apply to a certain group, or, which one has the biggest impact? Is profiling useful if you're not doing APM or something else, or are they always just kind of be adjacent to each other, and the more visibility you have, the better? Like, how do you make sense of kind of all the different ways that people can get information from their applications, but not be overwhelmed, if you will? Maybe that's sort of a good question for Hugo, since you're trying to manage all these.
Sure. So I think the most obvious answer here is yes, you need all the observability you can get, and profiling is sort of a unique visibility into your code, which APM sort of gives on a distributed level. So application by application, how long do my requests take by going through multiple services? But when you have to dig in a specific service, a specific application, what's taking time there? Request per request, profiling tells you that. And I would say that's one of our most important feature, which is what Markus described before as deep distributed tracing. It's really the ability for any request to tell you which are the methods that took time and why. Is it because they ran on CPU? Is it because the garbage collector ran at the same time, or they were locked, or any other type of data that we collect? So that's one. But it's not just related to application performance management. It's also related, as you said, to all the other parts of Datadog. If you look at an infra host that is burning up in CPU, then you can easily explain if it's due to anything related to infra or if it's related to the application. And if it's the application, then profiling will tell you that. We also have the same types of links from pods, Kubernetes pods that are burning up or that are maybe crashing because of an out-of-memory error. Profiling can help diagnose this. So as a first level, it's all linked together, and profiling is really this new set of data that is really key in understanding what's happening. But also not only. You could have profiling just like that without necessarily APM. And one example of this is companies that are running a lot of long data pipelines, so Hadoop jobs, Spark jobs, all that type of things that can run for hours. And in that case, you don't necessarily care about latency. You don't necessarily care about, the time taken to execute a request, but you care about, has it run on 10,000 nodes and blown up my entire cluster of Hadoop, or is it quite efficient to run? And in that case, you may only want profiling for this.
Gotcha. Makes sense. Yeah. And I think we live in a world where we've never had, so many applications, so much data, but now the tools to help us do it. And it's helpful to understand when does it make sense to use all the tools, but also when does it make sense to have one that's really specific and fine tuned for that application team, that SRE team. Guys, I want to be conscious of time. We're going to wrap up here. What's the best way if somebody says, hey, this sounds like something that could be useful to me? What's the best way to kind of get started with continuous profiling, working with you guys and getting started?
Profiling is I think one of the easiest tools to install at Datadog. You just start your application with the profiler, and that's basically it. You get data. You don't need to instrument anything in your code. You don't need to do anything. It just collects data and sends it to Datadog. And in a couple seconds or minutes, you will see profiles in Datadog UI.
Nice. So grab the code, get started, have more visibility. Very simple. Well, cool. Well, Markus and Hugo, thank you so much for the time today. Folks, as always, the folks at Datadog have always been good about helping us understand these new trends, whether it's observability, profiling, logging at scale, being able to integrate with all these different tools so you've got visibility. So we're really appreciative that they come back and teach us some more today. Guys, thank you so much for the time. Folks, as always, we appreciate you listening to the show. We appreciate you sharing with a friend, giving us feedback on iTunes and the other places you get your podcast. And so for Aaron and myself, we're going to wrap it up, and we will talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.